What about getting the power of a complex number in polar form? We'll actually do a lot more of this later on. In fact, let me show you. We're going to use something called de Moivre's theorem here. Let me just quickly show you your syllabus. So at this point, complex arithmetic using polar form, again, define and use powers of complex numbers in polar form and interpret geometrically. That's all we have to do at this point. But later on, we're going to have to, I'm just looking up Unit 4, we actually have to prove and use de Moivre's theorem. So we have to end up doing a lot more with de Moivre later on, and we certainly will. But for now, we're just going to try and use it to work out powers. Think about what this means. If I have R, can I do this nicely? R cis theta, and I want to put all of that to the power of n. Well, let me try first to the power of 2. What does that mean? Well, it means I'm going to multiply r by itself, and I'm going to get the argument and I'm going to add it to itself, which gives me 2 theta. Well, what about the same thing if I have to the power of 3? Well, that means I'm going to get what I started with. Sorry, I'm going to get my r. I'm going to raise it to the power of 3 because the length had been multiplied by itself 3 times. And then the argument, I've added the argument to itself 3 times. So what I end up with is saying this power up here becomes a power on the modulus and a multiplier for the argument. And that's what de Moivre's theorem says. Again, we'll come back to that and use it much more complex later. But for now, that's all we need to know. Raise the modulus to the power and multiply the argument by the power. Two cis pi on 4 to the power of 5. No, sorry, the whole thing here to the power of 5. Well, I raise my modulus to the power of 5, and I multiply my argument by 5. Okay, so far. But this is bigger than pi. So I need to go back the other side. I have 5 pi on 4. I actually want -3/4. Now you can leave it as 2 to the 5, or you can write 32. Textbook example had 32, but you can choose. I mean, 2 to the 5 is perfectly useful. But the argument should be -3 pi on 4. Go to the other side of the circle.